I was sometimes allowed to peer in through a sort of a blind door at the great water wheel that carried the work of the whole mill. It was so huge we could only watch a few of its spokes at a time, and part of its dripping rim, moving with a slow, measured strength through the darkness that shut it in. It impressed me with something of the awe which comes to us in thinking of a great power which keeps the mechanism of the universe in motion. Lucy Larkham.
Hi, I'm Ranger Chuck Arning, National Park Service Ranger here in the Blackstone River Valley National Heritage Corridor. Today we're going to explore water power, that natural energy that changed America from its rural bucolic landscape of colonial times to the clatter of looms and the thumping of shafts of the American Industrial Revolution. And that revolution started right here in the Blackstone River Valley. So join me, where water wheels still turn and some mills still use the river for energy, as we explore the technology that powered a youthful America.
All this machinery carried by one great wheel, it seems almost miraculous to think of it.
So wrote Julia Dutton, a mill worker, in a letter home to her mother. Some workers were fascinated by the power sources that turned American industry, while others shuddered at these powerful demons that no single person could control. And these diverse opinions of the mill workers reflected the same issues that Thomas Jefferson and Alexander Hamilton so hotly debated. The picture of the farmer citizen standing in his field, or the mill worker by his or her machine. Which was the real America? Was technology a word of evil, or a word of hope in the future? To understand the technology of water power and the changing role in America, let's track down Louis Hutchins, curator here at the Slater Mill Historic Site at the Wilkinson Mill Wheel Room in Pawtucket, Rhode Island.
Water power made the Industrial Revolution possible in America. The earliest factories, going back to Samuel Slater's Pawtucket Mill, was driven by water power. What's different about the early years of the Industrial Revolution is that, as opposed to the colonial period, water wheels were driving small operations like a grist mill or a sawmill. Here, the demands on water power were much greater. These water wheels had to drive factories with hundreds, thousands of spindles spinning cotton, or machines boring into metal parts and wooden parts. The water wheel allowed the Industrial Revolution to take place in America.
And yet it's a relatively simple technology, isn't it?
It is, but it changed dramatically in the early years of the Industrial Revolution. The wheel that we have here in the Wilkinson Mill came about really in the latter part of the 18th century, in the 1780s and 1790s, when mill owners needed to have a much more efficient way of getting energy out of the river. This wheel incorporates designs that really didn't exist before the middle of the 18th century. So what happens with the Industrial Revolution is that the demands on water power becomes much greater, and so people are experimenting with better ways to get energy out of those water wheels. What's interesting is before about 1750, if you set up a mill, a sawmill or a grist mill on some small stream in a small village in New England, for example, you relied on craft knowledge. That is, the people who were building the wheel learned it from their fathers and their grandfathers how to actually make the water wheel work. After about 1750, that changes, and people start experimenting with different designs. And that's when you get the great leaps forward in terms of water power technology. What water power does is it takes the flow of the river and it turns that horizontal energy into a vertical energy using a variety of shafts and gears. So that you take that vertical energy, that horizontal energy, and you turn that into a vertical energy. You're then able to take the power up through the floors and then onto counter shafts, which go the length of the building. This allows you then to operate machinery on every single floor of a mill. What's interesting, this mill had a variety of activities going on in it. There was a water wheel down here and a forge. On the first floor, this water wheel drove a machine shop, a variety, maybe a dozen or so tools to build machines. And on the upper floors, it was driving machinery for the cleaning and spinning of cotton. So this water wheel had to produce a lot of energy to make those machines operate. Actually, what's interesting is that Wilkinson, who owned this mill and built this water wheel, actually had a steam engine that assisted the water wheel at times when there were periods of drought or when there were periods of ice and the flow of the river was reduced. He would actually use steam power to assist his water power. But steam power in the early years was very expensive to operate. You had to get coal, you had to maintain the machines. The machines were not very well built because a lot of experimentation needed to be done with those as well. It's not till after the Civil War that steam engines become a more important power source than water wheels in this country.
In your opinion, how critical was water power in this spot to America's becoming an economic power?
Absolutely essential. The Industrial Revolution could not have happened without water power. That was true in England as well, but it was extremely important here. And that's why these centers along the East Coast that have rivers, the large rivers of Lowell, Massachusetts, and Pawtucket, going all the way up the valley to Worcester, these centers became very important engines for the Industrial Revolution and for industrial change.
The increasing need for power required a substantial leap in technology. Or did it? Just how different was the functioning of a water wheel for power and a turbine for electricity? Well, to answer that question, we're going to track down our good friend Todd McLish from the Blackstone Valley Electric Company. So Todd, just how great a leap in technology was it from a water wheel to a turbine?
Surprisingly, it wasn't much of a leap at all. The water wheel, for instance, the one at Slater Mill, is connected directly to power machinery. The water wheel, or the turbine that we have here, is connected directly to a generator, so the spinning turbine spins a generator. It's very similar equipment, very similar technology. It hasn't really changed too much in 100 years or more, and that's what's pretty amazing, I think. Here at Bridge Mill Power Station, our turbines generated about 1,000 kilowatts of electricity at the turn of the century, and that was enough electricity to power all of Pawtucket and even most of Woonsocket. Today, of course, we're still generating power here. However, we only provide enough electricity for about a tenth of the whole Blackstone Valley. So demand certainly has increased dramatically in the 100 years since this plant has been open.
That's true. We have a lot more gizmos that need power these days, don't we?
We certainly do. And it's interesting that 100 years ago, when we were just getting started here, we were really in the mode of trying to sell electrical appliances to try to encourage people to use more and more electricity, because that's how we're going to make our money. These days, the electric utility industry really has changed dramatically, so that we're actually encouraging people to conserve electricity.
One of the aspects about this that's interesting is that it still works, and it takes water from the Blackstone River and still turns it into power.
For the most part, it's a simple process. The water enters at the Main Street Dam here in downtown Pawtucket. It travels through an inlet tunnel about 100 feet and enters this building. The water then spins a turbine. The spinning turbine is attached with a shaft to a 9-foot pulley wheel downstairs. The spinning pulley wheel is belted up here to the generator right behind us, and the generator spins and makes electricity. Pretty simple process.
It really is.
That's what we did 100 years ago. We're doing the same thing with more modern equipment today. This room that we're in right now is the old generating room. Power was generated in here using this equipment that we see right here for 75 years, from 1896 until 1971. For the most part, the room was then closed down for 25 years until we were getting ready to celebrate the plant's 100th anniversary. We had installed new modern equipment downstairs, and this room was really abandoned. But in 1996, we were getting ready to celebrate our 100th anniversary, so we modernized this place. We found a gentleman who was willing to volunteer his time and restore all the original antique equipment, and we've opened it up as a museum. So now it is open for public tours by appointment only, but it's a wonderful place. We think it's the newest museum here in Pawtucket, and a lot of people who've never been here, didn't even realize there was a power plant here in the first place, have taken an interest in coming here and seeing what we've got to see. We are working with Slater Mill today even to develop a joint tour where people can see the Slater Mill and then come to our place for a combined tour, because we really do have one big story to tell between the two of us. We have the water power at Slater Mill from the 1790s. We have the water power here at Bridge Mill Power Station in the 1890s, and then we still have the modern story of the 1990s and water power here on the Blackstone River. So it really is a great story between the two of us. It's kind of a great experience for me to be able to talk with some of the retirees who worked here many years ago, one of whom, who worked here in the 40s, told me a great story how there was a mill across the river where Apex now is located, and the women in the mill used to wave at our workers here all the time, and one day the women decided to play a little joke on our guys by writing their phone number on a big board and holding it up to our guys. Our workers then ran to the phone and immediately dialed up the number. Come to find out, the women had given the phone number of the local convent. So our guys were not too pleased with that, I guess, but it was a pretty good joke played on them.
Well, tell you what, let's go over to the river and see how it comes into the building.
Okay.
Well, Todd, this is pretty amazing. Here we are standing right above the Blackstone River as it makes its way toward your turbines.
That's correct. This is the forebay, or the trash rack room, which, as I call it. This is really the favorite room of most people who come on a tour, because they really get a chance to see and hear and smell the river. But this is where the water enters the building, and the grate below us is the trash rack. Any debris that might be coming down the river, we don't want it to get stuck in the turbines, so we have the trash rack to catch all that debris before it gets tangled in our equipment. And of course, the worst job in the history of the company was the guy that had to take a 20-foot long rake, sort of like a quahog rake, and pull it up, pull all the garbage and debris and dead animals and other yuck out of the river. And in the olden days, we would just push the stuff back into the river through a hole in the building. When we modernized this place in the early 80s, we built this piece of equipment behind us, which is an automatic trash rack cleaner, which basically every 2 or 3 hours it automatically turns itself on, rolls down the railroad tracks that we're standing on, and automatically drops down its own rake, pulls up the trash, deposits it in a hopper, and that gets sent to the landfill. So we're sort of cleaning the river as we go along here.
Todd, any good stories connected with this room?
Well, actually, a couple good ones. My favorite one being the fact that next door to this building, earlier in the century, was a theater and restaurant. And the guys that worked here used to have to walk along a catwalk outside the building above the river to clean out the trash rack where the inlet tunnel began. Well, the theater and restaurant, whenever they had chipped dishes, they would just toss their dishes out the back window to land on the bottom of the river. And unfortunately, the dishes showered down on the heads of our workers who were carefully walking along the catwalk. A difficult job, and again, not anyone's favorite job. It really enters our inlet tunnel and goes through our building and back into the river in the process of about 200 yards or so. However, we do indeed have regulations that DEM establishes that tells us that we need to make sure that there's a certain amount of water in the river at all times, even in the area where our building is. So there are times when we do have to shut down because the river is so low, particularly during the summer months. There are 4 other hydro plants along the river, and there are issues between us all about use of the water and so forth. So there's a lot of management, there's a lot of technical aspects that we need to be aware of, but we're all able to generate electricity, and it's great to still see the river using its power to power progress here.
We've seen the power of water as it's controlled by dams. We've seen the power of a free-flowing river as it sweeps timbers and floats them downstream. And the amazing part of America's Industrial Revolution is the harnessing this raw energy by the many mills along the banks of America's rivers. Think about this for a moment. By 1880, There were more mills per river mile here in the Blackstone Valley than anywhere else in industrial America. And yet the question is, how did the mills harness this raw energy? Well, fortunately, Jim Knott, president of the Riverdale Mill Complex here in Northbridge, Massachusetts, has been kind enough to invite us to his mill to look at water power and get an understanding of how this resource has been channeled and used today to drive his mills. But when Jim says come in the front door, he means the front door, the power trench. Let's go exploring.
In about the mid-1800s, a new mill was built here. It's up on Riverdale Street behind us, and they put in another one of the old-fashioned water wheels, and then a few years later, probably 40 or 50 years later, they switched to turbines. And the turbines that are in this mill, the one that I'm running to make electricity, was built in 1901, and it is exactly like turbines that are built today, and it is just as efficient as turbines that are built today. And underneath the Riverdale mills are some huge granite arches. They were made out of granite because they didn't know about concrete back in the mid-1800s. And what's happened is I'm doing some work on them. We've had to get up in there and replace some of the floors, which were made out of wood. There are 3 arches because there were 3 wheels at the Riverdale mills. I'm only using 1 now, but they used 3 because they would play the flow of the river. They had a 75 horse, a 100 horse, and a 200 horse, and I have the 200 horse restored and normally running when we have water coming through this area. When I first saw those arches, I stood there and I looked up at this huge granite arch and I said, where am I? I just couldn't imagine from what you see in this building out on the street that there could be such an infrastructure in underneath it. And I thought about the work that went into making these things. What they did was they constructed wooden forms that were in the shape of the arch. They put wedges under them, lifted them up, and placed these huge granite blocks up the form to the keystone in the middle. And when those blocks were in place, they were able to pull the wedges and move the form downstream. And you can see where each of these creations was done. I was really amazed at thinking of the labor that went into that and thinking what such an arch would cost today.
Here in the 1990s, you're still using electricity generated from water.
That's right, we sure are. and it is the least expensive electricity we can possibly get. We use a lot of electricity, and we're in a business that competes all around the world, and we can use that little extra savings in costs to permit us to ship materials around the world, which is what we do. One of the interesting things about the Blackstone River is that it's often referred to as the beginning of the Industrial Revolution, and this river is called one of the most highly harnessed rivers in the United States. Now, what they mean by harnessing is, as I mentioned, we put up a dam here, and there's another dam upstream and another one downstream. Well, those dams were placed so that the water from one did not interfere with the water from the other, and they were placed essentially at every place that they could be between here and the Narragansett Bay. The power is from gravity. It's the weight of the water falling. And what we have over here, just beyond the building, is the dam that was erected in the meadow on the Blackstone River back in the 1700s. And what that dam does is it holds the water back. And by holding the water back, you build up what is called a head of water. And then when you release that water, the weight of the falling water is what turns the water wheels, or in today's parlance, the water turbines. And we'll see one up here that'll give you an idea of what's happening. The water goes through this device that looks like a stirring device. It turns it. The energy is transmitted up into a gearbox, and from the gearbox it turns a generator. And that's how the electricity is made. The weight of the water of the Blackstone River falling in that turbine is what turns the generator and makes electricity. We've captured the energy of the river with mechanical and electrical devices.
It is rather amazing to think about it, that here we are in the 1990s using new technology to create lobster pots and other kind of innovative products, and yet we're still using a technology, water power, that's been in this country for over 200 years. As a mill owner and an entrepreneur here in the Blackstone Valley, how do you feel about being able to touch base with the early entrepreneurs of the valley?
I think it just makes a lot of sense. They did the right thing back then, and we're still doing it now. You mentioned the lobster traps, and that's an interesting comparison, because the lobster traps have been around for about 300 years, and for years and years and years they were made out of wood, and they were a particular shape and size. And when I first got into the wire trap business, I was sure there was a better way to build a trap in terms of the shape and the size. And I made hundreds of different types of traps, and nothing worked better than those traps that had been around for 300 years.
So it's just the fact you had a different material that would last longer and take the use of the sea better than the wood.
That's right. That was the difference, really the only difference. Shape and size remains the same today as it did 300 years ago. Well, what I want to do, this was built about 150 years ago, and I want to make it last for another couple of hundred years. So what we're doing is we're using modern technology to hold those arches together and to replace those floors. And I'm convinced it'll be around for another 200 years.
The work in both the head race and the tail race for the Riverdale Mill has been completed, and the mill pond is back to its normal depth. Wintering waterfowl once again frequent the pond and river by the mill. And that complex relationship between man, technology, and nature continues to seek out a sustainable level of harmony. Well, this has been Chuck Arning, National Park Service Ranger here in the Blackstone River Valley National Heritage Corridor. And there's one aspect to the harnessing of the power of water, and specifically the new technologies that it helped create, that remain with us today. And that is the huge social changes that have been brought about by productivity based on these new technologies. No longer are our daily rhythms set by sunrise and sunset of the seasons, but rather the mill bell and the technology of the mills began to run the people's lives. And it all began here on the banks of the Blackstone River when Samuel Slater mechanized the spinning of cotton. And the issue of whether technology is good or evil is still hotly debated, for technology is still changing our daily rhythms.